And then welcome everybody back to the latest Collision Hub webinar. Today we've got Kelly Logan from Carliner, and Kelly's going to be talking about now Chris has got me thinking faster. Clips in my head. So we're talking about using the correct fasteners, a lot of rivets. It's going to be a riveting presentation. So looking forward to it. So without further ado, I'm going to turn it over to Kelly. It's all yours, Kelly.
All right, thanks, Jason. I'll go ahead and share my screen. Let me know if everything looks good, Jason, on your end.
You are good.
Okay. All right. I wanted to thank Collision Hub for letting me come on here and present. There we go. We'll get started here. All right. So today I'm going to talk about mechanical fasteners, rivets, for Kristen, and the importance of using the correct ones and on today's repairs, structural repairs of vehicles. A little bit about myself. So I've been in the collision industry my entire career. Started working in a body shop when I was 14. And just really fell in love with the trade. Grew up around street rods. My dad is a farmer in Nebraska, but always had old cars. And so I kind of grew up around working with my hands and working on old cars. And so that's how I ended up getting in the collision trade. Went to Wyoming Technical Institute and was lucky enough when I graduated to be recruited for BMW STEP program. And I was actually one of the first classes to go through the Performance Center down in South Carolina. So after the STEP program, which is a 9-month program for those who don't know about the apprenticeship program that BMW has, it's an excellent program. They basically take you, technician, and take the time to really educate you on how BMW wants their vehicles repaired. It was a 9-month program back then. It's kind of changed over time. I'm not familiar with it as much as I used to be, but back then it was 9 months long. And then when you get done, when you finish, the ultimate goal here is for BMW to have educated technicians going out into the field to work at the dealers and the collision centers. Was lucky enough to be offered a job at BMW at the Performance Center. The factory there in Spartanburg, South Carolina, has thousands of employees that lease vehicles, and they also wreck them frequently. So I ended up being a heavy collision technician for 9 years at the Performance Center. Actually left BMW and worked for Carliner. So this is my second time at Carliner. I worked there 12 years ago and was involved in measuring vehicles for data, training, software support, a little bit of everything. Kind of got involved in all sorts of different aspects of Carliner. Always wanted to have my own collision business growing up, and ended up, my wife and I decided to move back to Nebraska, and I had my own collision business for about 2 years. I had Carliner equipment when I had my own business. I was in rural Nebraska, so a lot of shops out there, much like in the Midwest. A lot of smaller shops don't have frame equipment, so they sublet it. So I had quite a few shops subletting me frame repair work. In 2011, I got a phone call from a past colleague begging me to send my resume to him. He had met someone from an unknown car company called Tesla at the time, and they were looking for candidates to start their own collision program. So my wife thought I had lost my mind when I went out to California in late 2011 to interview. I was really just curious about Tesla at the time, but ultimately decided to go to work for them. I was hired to recruit body shops for Tesla's collision program. Myself and another gentleman named Andy McDonald started the program. When I got there, realized that there really wasn't any type of service engineering group. And I ended up getting involved in many different aspects that I never dreamed I'd ever do in my career. But the Tesla Model S, they launched the first, I think, 10 or 12 in June of 2012. I started in February of 2012. We had no repair procedures, really didn't have anything in place when they launched the vehicle. So one of the many jobs I got involved in is I ended up becoming kind of a project manager for a lot of the repair research. So the Tesla Model S is heavily resistant spot welded in the factory, and obviously body shops do not have the capability to spot weld aluminum. To put it in perspective, steel vehicles, the spot welders on the market today range anywhere from 10,000 amps up to 16,000 amps. To be able to do that on aluminum, you would need a spot welder closer to 40,000 amps to be able to spot weld aluminum safely. So it's just not realistic at this point in time. So I ended up getting involved in project managing all of the SPR, the self-piercing joint, rivet joint project. We had to go through and create a joint matrix for every single joint in the vehicle that was spot welded. And then I worked with Ball Off on getting the joints narrowed down and the right rivets and the correct dies. I also then got involved in writing all the other different repair procedures where we researched structural blind rivets, countersunk rivets. I got involved in kind of researching how they build airplanes and even how they repair airplanes and even heavy trucks. So kind of researched on how different aluminum vehicles out there or airplanes and stuff that are built out of aluminum, how they actually repair them and build them, and was involved in a lot of research for these different repair procedures that we developed. And also the adhesive. Later this week, on Thursday morning, I'll talk about adhesives. And I got involved in the 2K two-component adhesive testing for Tesla because they had no 2K adhesives were used. The factory uses a 1K heat-cured adhesive that cures when it goes through the paint shop. So all this work had to be done. And I ended up getting involved in many of these steps along the way. And then finally, once we got the repair procedures developed and the program kind of in place, we developed a whole training program, an in-depth training program that included structural repairs, aluminum welding, mechanical repairs, and stuff like that. So a little bit about myself. Again, have done many of different things that I never thought I'd get involved in. But let's get into the presentation here. So talking about the different fasteners that are used, mechanical fasteners are used in today's collision repairs. I've got a bunch of different fasteners on the screen right now. If you look in the upper left-hand corner, that is a bunch of flow-form rivets. Flow-form rivets are becoming more popular in the collision repair industry. Daimler, Mercedes-Benz were the first ones to use this type of fastener for repairs. What's unique about these flow-form rivets is they actually are a fastener that was designed specifically for repair. When you look at the other fasteners on the screen, you'll see, self-piercing rivets, flow drill screws, solid rivets, structural rivets. So you got a lot of different types of fasteners that are being used in the construction of vehicles today, whereas a flow-form rivet was actually designed to strictly for repair. So right now, currently, Mercedes uses them, Cadillac, GM uses them on the Cadillac CT6, Tesla uses them. Just a great fastener. On the other side, on the right-hand side, you have self-piercing rivets. Those are obviously very popular. They've been around for many years. People are familiar with them. Ford uses them. Tesla uses them. Jaguar Land Rover. They're very, very popular fastener. And one of the main reasons they're popular is they're inexpensive for OEMs to build vehicles out of them with. Now, they may not be inexpensive for body shops when they get down, when you order them through your parts department, but for a manufacturer that's going to buy millions and millions of these a year, they are very economical for building vehicles. The fastener kind of in the upper center right there, that's a flow drill screw. Flow drill screws are becoming more popular as well. I know Porsche, Audi, Volkswagen are starting to use more of these. What's unique about this type of fastener, if you see that it's got a sharp point on the end, it's really purpose of this fastener is just to hold the panels together until the adhesive cures when it goes through the oven, when the paint shop in a car manufacturer. So the reason it has that sharp point is they spin this flow drill screw extremely fast, and it basically just penetrates through the metal, through the joint that it's going to be connecting, and it just kind of melts through the panel, and it speeds so quickly that it heats the metals up. And when it finally seats and it cools, the metal actually kind of locks down against those threads. So again, when you look at it, when you compare it to other fasteners, it's not the strongest type of fastener, but it's really just a economical way to hold the vehicle together until the adhesive dries. Down in the bottom left, you have just a structural countersunk blind rivet. These are very common. Countersunk rivets are great to use when you have areas where of the vehicle where you need to have them sit flush so you don't come in contact with anything. Down in the center bottom there, those are just solid rivets. Ford has used solid rivets on the F-150s, but these rivets have been around for many, many years. It's how airplanes have been built for a very long time. Just a really simple fastener. You have a hole, put the rivet in the hole, and then you just crush the rivet until it's tight. So very, very economical. Again, it's an economical fastener. The one above to the left of the solid rivets here kind of looks like a tack, a nail. That is called a riv tack. It's made by Ball Off. I'm sure there's other manufacturers as well. But this is literally just like a nail gun. If you look at it, when you compare it to the flow drill screw, it looks very, very similar. And again, this is strictly to hold the panels together during assembly of the body and until the adhesive can dry when it goes through the paint shop in the manufacturing plant. So again, this is just a very simple fastener, and again, it's kind of loud when they use these because it's like a nail gun. If you've ever built a house with a nail gun, it's just shooting these things into the joints. And again, it's doing it so quickly that the metal kind of grips around the ribs on that particular fastener. For this fastener, if you have to replace it in a collision repair, all you do is belt sand the head off and knock the stem part out of the hole, and you would replace it with a structural blind rivet. The bottom or in the center here kind of looks like a nut and a bolt with that bronze colored collar. That's called a pin and collar fastener. This type of fastener has been around for many, many years. The heavy trucking industry uses these. They build trains out of these. It's a very unique fastener. It's basically as close as you'll ever get to a nut and a bolt as a rivet. So what's unique with this fastener is you have to have access to both sides, but you stick the pin through, the bolt through, and then the collar slides over it, and the rivet tool that sets this particular fastener actually pulls on the pin, it pulls on the bolt, and then it basically crushes that collar down around those threads, and then it shears the leftover bolt off. So very, very strong fastener. It's a one-time use fastener. The last fastener in the bottom right is called a bomb fastener. Huck makes this particular fastener. BOM stands for blind oversized mandrel, and this is the world's strongest blind fastener. So initially Tesla built their all-wheel drive Model S's with these bomb fasteners, this is what held the front frame rails into the cast torque boxes. Very, very strong fastener. And again, they eventually swapped out and that just used nuts and bolts in the rails. But the first cars were built with these particular fasteners. Just a ridiculously strong fastener. To put it in perspective, when they drop Hummers out of airplanes, when they parachute them out of airplanes, the platform that the Hummer is sitting on is actually built with these bomb fasteners. So again, I just wanted to kind of go over a number of different types of fasteners. There are a lot more out there, but just trying to show you all the different types of fasteners that you're starting to see more of in the industry. The bomb fastener, you may never see that one again, but it is got some use in heavy truck industries. So depending on what vehicles you may repair, you could possibly see it. So kind of get into the evolution of vehicle construction. When you look at vehicles and the different types of fasteners like self-piercing rivets and the blind fasteners, you think in the beginning, 20 years ago, they were all high end, right? The picture in the upper left is an Audi A8, all aluminum. This is a very expensive high end car, required special equipment, special training. And, it was kind of expected, expensive vehicles made out of exotic materials at the time. You really need to, it would require special procedures to actually fix it. And that really was what drove the need for these certified collision programs or approved collision programs by OEMs. The Jaguar also had one of the first aluminum vehicles as well. And those were required a lot of specialty training. The bottom left picture that's actually a Tesla Model S with an A and a B pillar removed. Another part of my job that I didn't bring up earlier was because we didn't have any training in place and we didn't have repair procedures exactly documented, I would travel frequently to shops and actually work with shops to do the repairs and basically do on-site training. Just to ensure that our customers' vehicles, the Tesla vehicles, are getting repaired properly, and also to help our approved shops. So having an approved network of shops doesn't mean anything if you don't have repair procedures in place. So this particular vehicle, is hit very hard, and replacing the A and the B pillar, required aluminum welding, blind rivets, self-piercing rivets. So a number of lots of different types of fasteners. And this particular car was wrecked in 2013, so very early on. So this is one of the vehicles that I basically went in and worked with the technicians and the shop to get it repaired. So now, when you fast forward, you think about the differences and the changes in our industry and why lots of people, I like to say, it used to be easy to fix a car. Nothing's easy anymore in the collision industry. Fast forward to 2015 when Ford announced or launched the F-150 in all aluminum substrate. This is something that really, this is a mainstream vehicle that, no longer was it just for high-end vehicles, right? This was a mass-produced vehicle. The most popular vehicle in the U.S. is the F-Series from Ford. So, this has been a big challenge for the shops when, stepping into the aluminum repair. You had, pulse welding, rivet bonding. Granted, there had been rivet bonding in the past, but, just a lot of things to learn quickly when the Ford came out. And then now you fast forward, the bottom picture is a Chevrolet Silverado. This is the new T1 Silverado that they launched in 2019. This is the particular truck that we had on display at SEMA in 2018. But what's unique about this truck is, one, the entire cab is built with structural adhesive in the joints. But the other unique thing is the front end module of the truck now, the underhood has a inner structure. In the past, the Chevy pickups and GMC pickups always had the inner fenders that were part of the fender, and the fender was kind of a heavy duty structural part. Well, now the cab is kind of a unitized structure. But what's unique now is that this cab is spot welded together at the factory. But now in the repair side, you actually have options for rivet bonding during the repair. So no longer, even on steel vehicles, you're going to see more and more OEMs going to rivet bonding. And it has many different types of, or many different reasons why they're doing this. A lot of it has to do with the high strength steel. You know, a lot of it, you know, when you start welding, you can break down the strength of the metal just by heating it with the weld. You know, the adhesives, but a lot of it has to do with strength. The adhesives are actually stronger than weld. And we'll get into that a little bit on Thursday and talk about the adhesives and how they work together with the rivets. But today, again, I want to talk about the fasteners to kind of lay the groundwork down for Thursday's presentation. So I'm going to get into talking about structural blind rivets. You know, one of the things that I think when I think about rivets, and I know every time I bring it up, everybody gets a smile on the face, especially people that have been in the industry a long time. I always think about the Big Daddy rivet gun. And almost every technician has a Big Daddy in the bottom of their toolbox. And, you know, when you look at 1/4-inch rivets, the structural blind rivets that are used today, back in the late 80s, early 90s, Ford used some 1/4-inch rivets to hold their door glass regulators in the doors. And you would use your Big Daddy to set these rivets into the door to hold the regulator in. And those rivets back then, those were not structural. They were cheap, just peeled type rivets. And, you know, when people look at the rivets that are being used today, everyone just thinks a rivet's a rivet. And, you know, when I talk about structural blind rivets, when you're around this stuff, I spent a lot of time working with engineers and studying the different types of fasteners to make sure that the joint strength was there. You know, we talked a lot about structural blind rivets. So, you know, people like to call the rivets pop rivets, like, oh, it's just a pop rivet. Well, pop is just a brand. And in reality, they're either a rivet or they're a structural rivet. And basically the definition of what a structural rivet is it's just a brake stem fastener that offers a wide grip range for versatility and are designed for high strength and excellent clamp force. So how you tell the difference between a structural rivet and a non-structural rivet is all structural rivets actually lock the remaining stem into the rivet once it's set. So when you go to set a rivet and it breaks the stem off, and you see that little, especially like you think back about those Ford regulators, when you set those rivets, the stem always fell out at the end. So that was not a structural rivet. But when you set these new rivets that are holding, you know, on the T1 Silverados, when you're replacing that front end module, you know, frame rails, a lot of newer cars that are using that are spot welded at the factory, and steel vehicles may even use structural rivets to hold the frame rails in for the service repairs. But, you know, basically, the structural rivet will always have a design. They're designed to basically lock that stem in. And that, it helps keep the strength of the rivet over time. One of the worst things, and that's why there's so much testing that gets done on rivets, and a lot of testing done on adhesives, is you don't want to have degradation over time of strength of the joints. And so, you know, with that stem that's locked into that rivet, it really kind of wedges in there and it holds the strength over time. So again, if you guys take anything away from today, this presentation is just, you know, these structural rivets that are used today on Fords, on Chevys, on many other OEMs repairs, they're very specific to what the OEM needed for them to do for that particular joint. So, you know, talking another thing that's really misunderstood out there in the industry is grip range. And you go, well, what's grip range? Grip range is just the minimum and maximum grip that the rivet is intended to be used with. So grip is the thickness of a joint or of the metal that you're putting the rivets into. You know, every rivet has a specific grip range. Some rivets are very, very small tolerances for grip joint thicknesses. Other rivets have very wide ranges where you can use it in many different types of joints. But it's very important to understand that the grip range is not the length of the rivet body. I can't take a caliper and measure a structural rivet and go, oh, that's for this joint. You need to follow the OEM repair procedures, and you need to make sure that you're buying these rivets from the manufacturer, from your parts dealer, because not all rivets are the same. And, you know, when you buy these things off the internet from unknown people, there's a lot of things you don't know. And, you know, if they're not the same strength, joint strength, it can really affect how the vehicle reacts in crash. One of the most scariest things for any car company, any engineer that's designing a car, is not to have consistent crash. So what I mean by that is, you run a car into a wall 5 times, you should, at 30 miles an hour, you should have, within reason, the same results every time. And when you start changing things like fasteners, you're going to change the way the vehicle starts reacting. So I've got more information further on in the presentation about grip range, but I'm going to talk about 2 different types of structural rivets. There's bulb type, and these are probably one of the most popular type of rivets that are used by OEMs. I know Ford uses a bulb type, GM uses a bulb type rivet. There's different brands. The Huck makes a Magna bulb, that's their particular brand. And Stanley Abdale makes Hemlock. You know, Hemlock, Abdale was one of the first companies to come out with a lot of these rivets. So some people even refer to them as Hemlock rivets. But these are very strong, very good rivets for repair, but they have very specific grip ranges. So these are the ones that you really have to pay attention to the OEM repair procedures to make sure that you're using the right rivets in these different areas on the vehicle. You know, basically what a bulb style rivet is, it just expands in the back to spread the load over more surface area and creates a permanent clamp. So if you look at the pictures down here of the Magna bulb and the Hemlock, you can see they kind of look a little bit different from the side view, but the ultimate, once they're installed, it's the same type of bulb that kind of clamps down. These have a very high shear strength, so they're ideal for you know, collision repairs, especially like frame rails. When you look at them, when a vehicle gets into an accident, it puts the body into a big type of shear scenario where it's trying to pull those pieces of metal apart. So a bulb style rivet is something that's very common. Again, GM uses them, Ford uses them. You're going to see them everywhere. Another type of, on the grip range. So talking about the bulb style rivets, I got this particular screenshot off the internet from a rivet manufacturer. This is not specific to any OEM. I just wanted to give you guys try to drive home the point of why you have to follow the OEM procedures. Because if you take a look at this particular on the left here, the grip range. So at the top there, you can see the grip range. You have a minimum and a maximum. And I broke it down below it there in millimeters. It's much easier to talk in millimeters when you're dealing with the rivets. You can see the top rivet there has a 1.5 to a 3.5 grip range. So some metal, different pieces of metal stacked together, it can range from 1.5 to 3.5. And that's as much of a thickness as you could use that particular rivet on. Now, if you look all the way at the bottom, that particular rivet can work between 10.8 and 12.8 millimeters. So again, you've only got a 2 millimeter grip range variance. So these are very, very specific on the joint thickness that you would use these on. And again, you're not going to be able to look at the rivet just laying there in your hand going, oh, that's going to be for this particular joint. You got to look at what the OEM is saying. And here to drive it home further is, you know, the length of the rivet body. Again, you just can't measure the rivet body and know what the grip range is unless you had the part number or you have the particular data sheet for that rivet. That, yeah, and obviously you would know it. But look at the top one here. The length of the body is 13.7 millimeters long, but yet it's only designed to hold a 1.5 to a 3.5 joint. But if you look all the way at the bottom, the particular rivet body on the longest rivet in this style is 23 millimeters long, yet it's only holding that 10.8 to 12.8. So again, very difficult to just be able to look at this stuff and know what the differences are. So again, just following these OEM procedures, getting the rivets from your dealer or from wherever you can get the OEM parts is your best bet for repairs. Another style rivet here is a multi-grip rivet. Multi-grip rivets are very popular because they can hold together many different joint thicknesses. So I found the picture from Huck there in red there. You can see that's the same rivet throughout, used on all those different types of joint thicknesses. So again, this is one of the reasons OEMs like to use them is, you know, you can use that one rivet in multiple joints and you're not restricted like you are with the bulb style rivets. These are, you know, a very, very strong rivet as well. Abdel actually came out with the first multi-grip style rivet called the monobolt. So again, you'll have some technicians and people out there actually refer to these as monobolts. But again, it's just a name. Huck makes Magnalock, Stanley Abdel makes monobolt. But again, just a very strong rivet. And here I got the same information out of a catalog and just wanted to show you the difference. So if you look on the left here, and talking about the grip range, we'll look at the top rivet grip range. So that particular rivet can be used from a 2.03 millimeter joint all the way to a 9.53. So you have 7.5 millimeters of variance. So it's a very flexible rivet that can be used. And again, it's just as strong in that 2 millimeter joint as it is in that 9.5 millimeter joint. Just a very strong rivet. And then if you look all the way at the bottom, which is interesting, is you have a rivet that can go from 2 millimeters all the way up to almost 16 millimeters, 15.88. So again, a very versatile fastener. And again, look at the length of the rivet body here. The top fastener that has that 7.5 millimeter grip range, the length of that body is 28.42 millimeters long, but it's only holding, you know, up to a 9.5 joint. So again, it's a much longer rivet. The tail, the back side of the rivet, once it's installed, isn't as nice looking as like the bulb style rivet. But if you were going to go into a frame rail cavity or whatever, if you weren't going to see it visually, it really wouldn't matter. Bulb style rivets typically look nicer installed, especially if you have access to see the back side of it. And then if you look at the bottom rivet there, the length of it is 36.3 millimeters long. But yet, when you look at the grip range, it's only covering 2 to nearly 16 millimeters. So again, just trying to drive home the point, you can't just look at this stuff and know. You really got to look at what the procedure is saying to make sure that you're using the right fastener. So talking about different rivets now, and those are just a few. You know, obviously you can have countersunk structural rivets. and many other different styles. But one of the biggest questions that I get is, what rivet gun should I buy? And, you know, GM recently relaunched their collision program, and one of the things that they spec'd out in their tool requirements was having a blind rivet tool that had a requirement of 3,822 pound force. So that was the first time, really, when you look at it, where a spec on a rivet tool is really publicized. And obviously with GM, they have a lot of vehicles, so there's a lot of shops in their programs. But there's a lot of confusion out there. And believe me, I get confused at times, because different OEMs will have different requirements, spec requirements for the rivet tools. And different OEMs, or different tool manufacturers will actually advertise their rivet tools in different types of specs. So when you look at all these different types of rivet tools on the screen here, I had to put the Big Daddy up there in the left-hand corner again. Almost every tech has those. I would not recommend using these on these strong structural rivets on vehicle repairs today. Can you use them? Yeah, you can, but it wears this gun out quickly, and you don't know if you properly set that tool. And another thing, with a manual rivet tool, you're not going to get, you know, it doesn't have any type of force designation, stroke designation. So it has no rating. So when you look at, you know, a couple different rivet tools here, that bottom left rivet tool that's in red, it's made by Huck. It was a popular rivet tool for the Ford program when they launched the F-150 program. It's rated at 3,500 pound force. The rivet gun next to it, that's rated at 25 kilonewton. That's a particular rivet tool that Carliner sells. It's made by TKR. It's a great rivet gun. It's very flexible, very, very strong at 25 kilonewton. The green gun here is made by Marson. It's rated at 20,000 newton. And then, obviously, a lot of people have these Marson handheld rivet tools in their toolboxes as well. ProSpot has a blind rivet tool attachment on their SPR tool, and it's rated at 20 kilonewton. This rivet tool up here with the question marks that's in gray, this is actually the rivet tool that's sold by Harbor Freight. And when you look at the different tools out there, and I see a lot of these out there, Harbor Freight has no designation of force on this tool. I've never been able to find anything in the owner's manual, anything in writing, anything engraved on that tool. So you really don't know what you're using when you're using this tool. Is it cheap? Yeah, it's cheap. But is it setting the rivet to the right force? I have no idea. The final rivet tool there is Carliner's new CBR 2000. This is rated at 4,496 pound force. So I realize I'm throwing all these pound force and kilonewton and all these different designations, but what's interesting here is the Carliner battery operated tool there, 4,496 pound force, the Marson 20,000 newton rivet tool, and the ProSpot 20 kilonewton tool. These are all saying the same exact thing. So when you look at the different designations, it's all a unit of force when they're talking about setting force. Pound force. When GM came out with this particular spec, I had never heard of it before, but it's interesting when you look at it. Pound force is just kind of like a standard tape measure, and then newtons and kilonewtons is like a metric tape measure. That's the easiest way for me to break it down. So pound force, you're going to see it here in the U.S., not really seeing it anywhere else as far as how they describe tools. As far as when you work with fastener engineers, they all talk about kilonewtons. Kilonewton is just 1,000 newtons, so it's just easier to say kilonewtons, because 50 kilonewtons is 50,000 newtons. So it's just an easier abbreviated way to say it. So another question I get a lot is, well, which rivet tool should I buy? And the good thing with the OEMs is there's not many OEMs out there that actually specify a particular brand of blind rivet tool. Most of them just have a spec. And so, you know, what do you want to look at when you're going to buy a rivet tool? One is capacity, the diameter of the rivet for body shops. You guys are using 1/8 inch, 3/16, and the most common today are 1/4 inch rivets. They do make larger rivets. They make 5/16, they make 3/4, they make much bigger rivets. But for collision repair and automobiles, 1/4 inch is pretty much the max size that you're going to use. Again, there's exceptions, but I would say 90% of the vehicles out there, you're going to be fine with a good rivet gun that can go up to 1/4 inch. Stroke. Stroke is an important one. You know, you want to have a minimum of 3/4 of an inch or 20 millimeters. And the longer the better. And the stroke, all that is how far the tool can pull the rivet before it needs to reset. So if you've ever used a rivet gun, or even like a Big Daddy where you're having to constantly crimp it down and reset it, the stroke is important when you're looking at a blind rivet tool. You definitely want to have a minimum of 20 millimeters, and a 1 inch is actually best. And then pulling force. It's just like anything, more power. Having the higher pulling force, again, GM's spec is 3,822 pound force. Having over that is not a bad thing. And again, Newton, pound force, kilonewton, they all mean the same thing. The great thing about the internet is being able just to, you can search in a calculator on how to convert kilonewton to newton or to pound force. So it's not very difficult. Anyway, Jason, that kind of wraps up on the blind rivets before I get into self-piercing rivets, but I'll take any questions that we got right now.
We don't have any questions coming in yet.
Okay. All right. That's not a problem. I know I'm going through a lot and throwing a lot at them, but you know, especially on the blind rivet tools, it is important to have a good brand of rivet tool. And here's another thing to think about. I mean, obviously, I work for a tool company, and everyone's going to say, well, yeah, of course he's going to say that. But it's a good idea to really think about having more than one quality blind rivet tool in your shop, because nothing's worse than you're trying to glue a side of a bedside on or any type of structural repair, and your rivet tool breaks, which it happens. Mm-hmm. And then you got wet adhesive, and you're trying to figure out what to do. It's not fun. So, you know, rivet tools are going to become like welders. Well, they already are very rapidly, right? You're going to have more than one rivet tool in your shop, depending on the OEM. But especially on the blind rivet tools, it definitely pays to have a quality rivet gun for these types of repairs today.
No.
Cool. All right. Well, I'll get into self-piercing rivets now. So again, self-piercing rivets. You know, what's the definition of an SPR? A self-piercing rivet is an environmentally friendly method of joining two or more sheets of material in one simple, fast operation. Again, this is something that OEMs like to use, SPRs, because they're very cost efficient. There's not a lot of consumables. When you think about spot welders in a factory, you know, you got caps on aluminum vehicles. Some spot welders out there actually have stainless steel tape that will turn every spot weld the tape moves, and you have a clean sheet of stainless steel to use. So there's a lot of consumables. They create a lot of sparks. There's a lot of different things. But one of the things that's interesting and deceiving with self-piercing rivets is once you install them, you really don't know if they're installed properly. And I like to show these side cut views. When an engineer, a fastener engineer, studies a SPR joint and they're trying to figure out what the correct rivet and what the correct die is, they're gonna take coupons like this, set the rivet in to the material. They're gonna cut it in half, and then they're gonna polish this and then put it under a microscope and actually measure different aspects of the joint. So when you look at, and I hear this from technicians, and it makes me cringe every time, where technician just says, I use the same rivet for every joint. It doesn't matter. I use the same die. It doesn't matter. A lot of technology and a lot of research goes into these joints, and it's a mechanical fastener. So this particular joint, while with the SPRs, you're always going to typically use adhesive. The SPR joint itself is completely mechanical, where it locks the rivet into the different types of or thicknesses of metal here. So looking at the advantages of SPRs when you're looking at it from an OEM perspective, they can join many different types of materials. So you look at steel and aluminum and magnesium, cast aluminum. All these things can be joined very easily with self-piercing rivets. You're not going to be spot welding steel and aluminum together or steel and magnesium together. It's not going to happen. So with these rivets, the SPR rivets, it's a very flexible fastener for many different types of materials. And another thing you look at it is faster cycle times. In a factory, a robot can install many SPR rivets very quickly, and when it's set up properly. It's compatible with adhesives. It can join, obviously multiple layers. It doesn't make a lot of noise when you install the SPR into the metal, when you think about spot welding and sparks and stuff flying around. So again, there's a lot of advantages with SPRs. And most of it, again, it comes down to cost. To put it in perspective, car companies buy millions of these rivets, and they'll end up paying less than a penny a piece. But then when you go to buy them at your local dealer, you guys may pay, $100 for 100 of them. Again, it's just a lot of it has to do with, selling the rivets in smaller quantities and going through the parts department. But it is, again, very important that you use the OEM specified rivets. Here's, again, trying to go into the tools here. What does it all mean? Many different SPR tools on the market these days, and you'll see them talked about in tons. You'll hear it in metric tons, like 6-ton tool, 10-ton tool, and then you'll see kilonewtons. And so when you look at all these different types of rivets, the one in the upper left-hand corner is a 50 kilonewton tool. That particular rivet gun I sold through Tesla early days, and it was provided to me by Baloff. Henrob also used that same tool. Some of your shops out there may have these. When the F-150 program launched, Henrob had this tool as well. Again, it's a very versatile tool, battery operated, pretty quick. You look at the rivet tool at the top. That's Carliner sells this particular rivet tool. It's made by TKR. It's a great rivet tool. It's been around for many years. BMW uses them. Again, has many OEM approvals. It's rated at 6 tons or 60 kilonewton. Willinger & Schill, the Express 800. This is another popular rivet tool for different OEM programs. It's rated actually at 77 kilonewton. I just rounded up to 80. But again, a very flexible tool. When you look at the bottom right here, the PMP 90 XT2, this is another rivet gun that Carliner sells. I get this question all the time, and I talk to many shop owners and about, well, I only want to buy one rivet gun that's going to cover all of the OEMs. I'll just tell you right now, it doesn't exist. You can buy some rivet guns that will have a majority of the OEM approvals, but there's no rivet gun on the market today that has every single approval. And a lot of it has to do with the car companies. A lot of this joint technology is very intellectual property. They don't like to, it's not something they like to share. So depending on the rivets companies that they utilize could be why the rivet tool is approved or not approved. Again, there's just so many different types of scenarios with these rivet guns. But when you look at this XT2, it's rated at 100 kilonewton, 10 tons, which is ridiculously strong. It's hard to put into words how strong 100 kilonewton is, but the reason this rivet tool was developed, it was actually developed in partnership with Mercedes-Benz, is Mercedes needed to be able to punch holes in the high strength steel B pillars on some of their cars. And unfortunately, you're not going to get that. You're not going to be punching holes through high strength steel with a 60 kilonewton gun or a 50. You know, you need 80 kilonewtons or more to be able to punch through this tough steel. So again, you know, when you look at these different rivet tools, you know, and Pro Spot Rivet's gun here is rated at 50 kilonewton, and then Dent Fix's particular rivet gun is rated at 80 kilonewton. You know, again, many different types of rivet guns. You really just need to look at what vehicles you're repairing and make the decision there. The XT2 has many OEM approvals, and so, you know, it works. But the 60 kilonewton tool above in the center there has a lot too. It's just not as strong. But if you're, you know, working on Fords every day, in reality, that smaller 60 kilonewton tool is actually more than enough than what you need. So, you know, again, it depends on what you're looking at. But, you know, going in the future, you're only going to see more riveting and adhesives and repairs. And you're going to see more rivet guns in shops. Again, there's just not one rivet tool out there. To put it in perspective, when you look at the Volkswagen, Audi, Porsche program, they sell their own rivet tool through the program. So even though you could have 3 different rivet guns, if you wanted to become Volkswagen, Audi, or Porsche approved, you're going to have to buy their compact booster rivet tool to be in their program. So again, you know, to put it in, to kind of give you some insight on a Model S, the strongest joint on that particular vehicle is only like 42 kilonewtons, and that joint is in the B pillar, putting a SPR rivet into steel. So, you know, and so that's why that battery operated 50 kilonewton tool was more than enough. And so when you look at the different types of vehicles that you're going to be working on, not necessarily more is better on the SPR tools, like it would be on the blind rivet tools. It's just, you got to understand, you got to look at what OEMs you're working on, or maybe what you're going to look at to get in the future for the repairs. But again, it's really a lot of these stronger rivet guns that have come out in the last few years. It's mainly for them to be able to work on steel cars with this high strength steel. So again, you know, what does it all mean? Talking about kilonewton, newton, and metric ton. These are all metric forms of measurements of mass and force. And again, they cross over. A metric ton is equal to about just shy of 10 kilonewtons. So, you know, a 60 kilonewton tool is 6 tons. So just some insight on the different lingo, but it can be confusing when the different OEMs talk differently as far as the different types of standards for measurements of force. So another thing too that is misunderstood out there on SPR rivets is, you know, there's 3mm rivets and there's 5mm rivets, and people think that is the measurement of the top of the rivet. But in reality, it's actually the barrel, the part of the rivet that gets pressed into the metal first. That's the actual measurement, and that's how we identify it. So it can be confusing because you'll have a 3mm rivet, but the top of the head, if you measure it with a caliper, it measures 5.5, and then an actual 5mm SPR measures at almost 8mm. So again, you know, this is where that measurement comes from. Ford, all the OEMs use 5.3 or 5mm rivets, self-piercing rivets. I know BMW uses some 3mm rivets, some of these smaller ones. But again, the measurement actually comes from the barrel part of the rivet. So another important thing, again, when you look at rivets and what you can't see, and this really pushes the need for getting your rivets from the dealer, from the OEM, is all rivets, including blind rivets, are coated with anti-corrosion materials. and it's clear. Most of the times you can't tell what's on them. It's a clear coating. I like this picture. This is from Ball Off. It's a great picture of a self-piercing rivet. So the green part is the actual rivet, and the other coatings, there's actually 3 different coatings on this rivet. There's a copper coating, there's a zinc tin, and there's a zinc tin aluminum and a tin aluminum. So all these coatings on this rivet are for anti-corrosion. And when you start buying rivets off the internet, I'm not saying they don't have coatings on them, but you have no way of knowing what you're buying. And again, if you're getting this stuff and it's coming from overseas and you have no way to trace it, and it's not like the OEMs print this stuff out there for you to read in a repair procedure. You're not going to know what coatings are on the rivets. But this is, a fastener engineer at a car company today, they study and they research corrosion protection, and they spec out different corrosion protection properties on rivets, and they vary from car company to car company. So, I mean, that's when you look at the life of a repair, especially when you're doing a repair in a body shop. It's important that you use the appropriate fasteners to make sure that the life of the repair, it lasts forever. So, looking at the 4 steps of how a SPR rivet is installed, I found this kind of picture view of a side view of how a rivet is installed. So there's 4 steps. There's piercing. It's when the first rivet first makes contact and it's going through the metal. There's penetrating, where it's going in through the second layer and starting to form. Then you have forming, and then you have set. So if you look, when it first started in piercing, the rivet is very straight. The barrel of the SPR rivet is straight, and then as it's getting set, it's actually bending. The rivet outward, and that's where that mechanical lock comes in. That's how it's locking those 2 pieces of metal together. It's using the rivet and it's using the proper die to shape that particular joint. And again, if you're not using the right length rivets, and one of the things that I see out there a lot is technicians using too long of a rivet. And I get this question a lot where they go, well, the rivet won't sit flush. It just sticks up. You're using the wrong length of rivet for that particular joint. And, and then the other thing too is, I just use the same die for everything. They have different dies for different joints, because that's the best joint for that particular, for those particular pieces of metal. And, when you look at what a fastener engineer looks at when they are developing a joint at a car company, this particular picture is from Ball Off. Of a particular joint, and you can see this is when they set it into a coupon, they cut it in half, and then they put it under a microscope, and they actually measure it. And so you can see all these numbers all over. But one thing I like to use is this picture is, if you look at the bottom there, they've got 0.39 of a millimeter and 0.37 of a millimeter. I mean, this is stuff that you're not going to be able to know what to use without following the guidelines from the OEM. Again, these few pictures here, these few slides, I just like to show the flexibility and why you're going to see more self-piercing rivets in the future. For the first joint here on the left, the steel and aluminum, and then you have one that's steel, aluminum, and steel. The one on the right here is 4 layers of steel. So very, very different types of substrates. Very, very flexible. And here's one, you've got aluminum in cast magnesium, and then you have like a polymer plastic in aluminum, and then also aluminum into cast aluminum. It just you can just see, it's a very flexible fastener, and you're not going to be joining these types of materials together with a welder. And so again, these are things you'll see more of in the future. So that kind of wraps up the discussion on self-piercing rivets, and I'm going to go into some OEM repair procedures and kind of point out differences now, Jason. So if there's any questions, I realize there's a lot of information, but
yeah, still no questions coming in. But I think one thing that I think is interesting, worth noting, is a conversation I had with Jerry Benani from Ford at SEMA. He was seeing a lot of rivet guns that were out there that were coming with rivets, supplied with some rivets. And his concern was, that just as you clearly demonstrated here, I think that, not all rivets are the same. And just because it's the same diameter and the same length for a particular application does not necessarily mean it's what's the appropriate rivet for that replacement procedure.
So just to kind of put it into perspective for everyone, and do not, like, this is rough. But when you look at a SPR rivet and you look at the joint thickness, and you're like, well, which rivet? A rough idea is it's the joint thickness plus 2 millimeter will roughly give you an idea of how long that rivet needs to be. Now, I was told the last time I did a presentation that, and that was what Baloff used. And again, they always backed it up with actually doing the joint analysis. But I was told in the last presentation that Henrob, who does Ford repair, or Ford builds their vehicles with Henrob rivets, that it's like 1.5 millimeters plus the joint thickness. Again, if you wanted to look at an idea of what rivet would you use, but again, you got to follow the OEM procedures to really know. But I get that question a lot, and if you're going to do a demonstration on a rivet gun, like for our distributors, I use that kind of rule of thumb.
Yeah. Yeah. Use the rivet specified by the procedure, and you'll be good. So, all right. So cool. Yeah. Carry on.
Cool. All right. So I'm gonna pull up a couple of different OEM repair procedures, and I just wanted, one of the things that I hear, and I've heard it 3 different times now in 3 different parts of the country, is shops will tell me, well, my parts guy doesn't know what rivets to order. And honestly, that's a key indicator to me that the technician isn't, or the shop isn't looking at the OEM procedure. All procedures from the OEMs, if there's a fastener involved, will identify the correct fastener. Now, they may not give you all the information, like the grip range and stuff like that, but they will spec it out. So I took a Ford bedside, for instance. This is a very popular repair. I'm sure many of you guys out there have done this repair. You can do welding, you can do blind rivets. I know Ford is going to be adding self-piercing rivets now. Jerry Benani told me that at Ford. It may already be out, I'm not sure. But this particular procedure is the bedside. And I just wanted to, point out, on the left side, this is like the first page of the repair procedure. It's giving you the rivets, it's giving you the adhesive, recommended adhesive. It's giving you all the information, the part number for the bedside, all of the information you really need. And towards the middle there, you'll see that you're going to need 53 of one blind rivet, you're going to need 4 of another, and then you've got 2 bolts, and then adhesive.
Hey,
so
this is real quickly, Kelly. The one thing I want to point out here,
yep,
because it's still, for whatever reason, people are still confused by this procedure, that there are no self-piercing rivets for this particular application. These are blind rivets or plug wells on these box sides.
Okay.
So
so Ford hasn't launched that yet.
No, I still get the question all the time, and I know they're doing some testing on it, but unless it's changed very recently, but it's still, as far as I know, it's still blind rivets or plug wells only.
Yeah, yep, and exactly. And I know a lot of techs out there like to use the SPRs because visually it looks better. But I don't know. Again, this is what the procedure is today. So I can't comment on it. But this particular, I just wanted to kind of put this in perspective for you guys on grip range. So there's 3 different types of blind rivets that Ford likes to use. And if you look, I had to do some digging to get the grip range, but if you look like this front edge of the bed, it calls for 11 of these particular blind rivets that have a grip range of 1.5 to 3.5. And then, but if you look at the very top there's 2 rivets identified with a different part number and in the shape of a square. But if you look at that particular joint or grip range on that rivet, it's 2.8 to 3.8. So again, you know, obviously that joint at the top has a joint thicker than 3.5. Otherwise, Ford would have just used the same rivet throughout that front edge of that box. And if you're using that same shorter rivet up there, that joint could fail over time, especially on a bed. But one thing I see more so than others is, for whatever reason, there's a third popular rivet, and it's got a much longer grip range. It's got a 6.8 to 8.8 millimeter grip range on the rivet. And I see technicians using these everywhere, like using them on the real thin sheet metals. Well, what happens is it may pull them together to get the adhesive to cure, but over time, when you think about, you know, durability, that's one of the things that fastener engineers and adhesive engineers study is durability of the adhesive, durability of the fastener. And you think about, I always think of Michigan, right? Because I go up to Michigan frequently, and the roads, man, they have some big potholes. I mean, pick Chicago, take another city, big potholes. And you think about the life of a repair where it's going down the road, bouncing off potholes, jarring the body structure. And, you know, this is where it's really important you want to make sure that you're using the right rivets, because it's gonna hold that joint together over time, and using the wrong rivets is only gonna cause that joint to fail, especially when you look at the next one here. So talking about the T1, the new 2019 Silverado that GM launched. Again, the front end structure is spot welded at the factory, but now it's actually, you're using structural rivets to replace this during the repair. And one thing that GM does nice is they have a fastener specification area in the repair procedure. It's hyperlinked. If you looked up on this, on the right there, you can see it calls for 4 rivets. Well, it's calling for 4 SR1 rivets. And well, what's an SR1? Well, you click on the hyperlink to the fastener specification, and you can see GM's giving you the grip range. So it gives you the opportunity to buy them in quantities of 1 or quantities of 30. But again, if you look at the other rivets that are available, you have 3.3 to 5.3 for the SR2 rivets. You have 4.8 to 6.8 on the SR3. So again, something like this particular repair, there's airbag deployment involved with this particular repair, right? So if this thing is, and you're putting it back together, and for whatever reason you grab the SR3 rivets, if this thing ever got into another accident, it would not react the same in a collision. So again, it's something you want to take seriously when you're doing these repairs, because this is something that it is important to make sure that you're using the proper fasteners. And so I'm going to get into just a personal experience of mine here. I always like to put it in perspective for people, real world damage. This particular Model S, this was in, I think it was in 2013 on this particular car. This was up in Quebec, Canada. And I don't know the details, but a motorcycle either hit this car or this car hit a motorcycle. I don't know what the outcome of the guy on the motorcycle was, but he definitely hit this car, or this Model S definitely took a hard impact. So this particular vehicle needed a B-pillar and a lot of replacement parts in the inner wheelhouse. I went up to Quebec, and I did on-site training. We actually replaced the entire uniside of this vehicle, the outer sheet metal. But the picture on the right here to show you how hard this vehicle was hit. This is the inner B-pillar, and there's a very thick 3mm gusset that is welded and bonded in place, and it actually cracked the weld on the gusset. The car reacted the way it should have in that type of accident, so the engineering was very good on that particular, the B-pillar on this vehicle. But you can see it's got a lot of damage to the inner wheelhouse of the quarter. So this particular picture, you can see we actually have the outer body side removed. We got the B pillar out of the way. Just to say, we could have left the A pillar outer sheet metal on, and we could have sectioned it at the top and the bottom of the A pillar. But in reality, it was actually faster just to remove it and replace the entire body side. When you replace the entire body side, then you didn't have to have any sections, no welding. You didn't have to do any type of filler work to finish the joint off. So it was a really nice, clean repair. You can see here, everywhere where you see that orange adhesive, that's the factory adhesive that Tesla used. It's a 1K adhesive. Again, this is the stuff that cures when it goes through the paint shop. But this was very, very tough stuff. And again, a very large repair. And we had to do it in layers. So when you look at the first step was just replacing the B pillar, and also as well as the inner structure of the wheelhouse on the quarter panel. So we replaced we did it in steps. The B pillar is one of the largest repairs on a Model S, just because you have to remove the sunroof, obviously the interior, and then there's welding, there's riveting, there's bonding. I mean, there's all sorts of, there's every step of fastener involved on this repair. And then you can see the body side here just loosely put on the car. Again, it just replacing the entire uniside of the vehicle, it just made it a nicer repair and actually faster, because you didn't have to do any type of filler work or welding or anything on this particular vehicle. So with this one, you can see this picture actually shows all the adhesive applied before we put the uniside on. This particular shop took the time and they painted the inner structure and the B pillar inner structure before we put the uniside on. I mean, they wouldn't have needed to do that, but they really wanted to do it and make it, just to complete a really, really nice, clean repair. So they painted it the night before we came in to put the uniside on. So you can see there is adhesive everywhere on this particular vehicle. All the joints that you can see, we put it on both sides. And I actually was training 2 technicians on this repair, and it took all 3 of us when we were installing rivets to get this uniside on. Luckily, it was in December of, it was in February in Quebec. So it was not the warmest out, so it allowed us a little bit of extra work time on the adhesive before it set up. So again, this is a very large repair. But the reason I chose this car to talk about is, one of the things that we went over in training on technicians is, with these rivets, you're going to have all these different sizes of rivets. You're going to have different dies that you're going to use, mandrels that you're going to use on the backside. And the only way to accurately repair the vehicle is to I called it blueprinting. I realize blueprinting is kind of a overused term these days on the estimating side, but just taking the time to write and what those numbers mean on the pictures there, that's just the length of the rivet. All of these rivets were 5.3 millimeter rivets, but Tesla had like 10 different lengths of rivets. It was a lot of different lengths. So if you look at the picture on the left, you can see 8s written, and then there's 5s. The other numbers there, the 488, 1300, that's the actual die number. And that was called out in the repair procedure. The middle picture there, you can actually see 6 millimeter rivets, 4 millimeter rivets, 7 millimeter rivets. And then at the back of the quarter there, you can see 4 millimeter rivets, 4.5 millimeter rivets, and 6 millimeter rivets. Again, just, if you're trying to put this huge body side on this vehicle, and you're trying to look at the OEM procedure and grab a rivet and do it each time, it really is painful. So any way that you can speed up the process, it allows, it just makes the install so much smoother for everyone involved. So you can see here on the A-pillar, we had, structural blind rivets in this particular repair, and SVRs. And then on the middle picture here, we had 5 millimeter rivets at the top and 4.5 millimeter rivets at the bottom. and both those rivets used a different die. So again, writing this stuff out, kind of blueprinting out it on the panel really saves everyone a lot of time to when you're actually installing this, and especially when it's hot out. When it's warm out, I'm sure all of you guys have experienced that. When you're working with adhesive and it's warm, man, you've got to hustle. And trying to do a large repair like this, it was, not going to lie, it was nice that we had the cooler temperatures outside, because it actually bought us some time. But it took us about an hour, all three of us working together to get this uniside all riveted in place. And then the last picture, excuse me, is just them kind of finishing up the last few rivets on this uniside. So again, just wanted to show kind of a real world scenario where you got all these different types of rivets, and you know, making sure that you follow the repair procedures. So that's all I've got. I appreciate everyone taking the time to listen to me. Again, on Thursday morning, I'm going to talk about adhesives, and not so much. I am not an engineer. I'm not an adhesives engineer, but I'm going to talk about what OEMs go into and what they do and what they test to be able to decide what adhesives to use. So again, I'm open for any questions.
Anybody got anything for Kelly? No. Let's see here. Maybe grab the. You can either raise your hand or use the chat or the Q&A. We got Kelly here for a few more minutes. Not. Oh, we got one here. Does it take different time, Kelly, to set up for various riveting equipment?
So when you look at the different SPRs, and you know, blind rivet tools, you know, for the most part, they're using 1/4 inch, or they're using, you know, 3/16 rivets. So, you know, changing the nose, that's pretty simple. It's not that complicated. SPR tools, especially when you look at different areas of the vehicle, if you're doing like a shock tower on a cast shock tower, and you're trying to doing the SPRs and the different fasteners, it's, you know, you may have to change the yoke, the C-arm on it multiple times during the repair. But actual setup of the tool, it's not that long. I think it's more when you're going to put like a large panel on, and I'm talking, you know, SPRs. Blind rivets are fairly simple, right? Because the tool, as fast as your tool works, is how fast you can set them. Where on SPRs, you gotta kind of map out all the different sizes and the dies, and that will help you be more efficient. Because if you just rush into it and just try to read it off through procedure, it is going to take you a lot longer. So another thing to add to that, and you know, is having a second person just hand you the rivets really helps speed things up. I realize that's not realistic sometimes for shops and busy shops, and everyone's trying to get a lot done. But man, just having one extra person hand you the correct rivet will speed up the repair immensely.
Other questions or comment? Looks like more here. Outstanding information. I would agree, absolutely, Mario. Seems like we need to start documenting in a different fashion, similar to aviation repairs, and document correct position of every fastener. Perhaps taking pictures may not be the answer. Anything out there different to document the procedures?
Yeah, that's a good point. I mean, you know, obviously, when you look at the different repairs, it's you know, just following, you know, buying the rivets from the dealer with the right part numbers and stuff. You know, those are key. But you know, actually looking at every area of the joint to document that, I don't know how you would do that. But I mean, it's not like it's not a good idea. You know, taking pictures. You've seen the pictures that I had on that Tesla where we showed all the different dies and we showed the different rivet lengths. So, I mean, there is a way there. I just don't know, is that realistic for a shop to do that? So
make sure you've got your, you know, the rivet orders and whatnot.
Yeah, correct.
Great question here from Danny. Should we do a rivet setup / test riveting process similar to welder setup?
You know, I've gotten that question in the past. And, you know, with SPRs, there's not a really way to measure, right? Like with a spot weld, you know, you can do it basically like a peel test where you're just peeling it apart with some vice grips, and you know if that thing's holding. To put it in perspective for you on an SPR rivet, an SPR rivet isn't the strongest fastener. It works in conjunction with the adhesive, especially when you start looking at it at a peel environment. And what I mean, and I'm going to talk about this more on Thursday, is you know, shear and peel and a wedge environment where in an accident, when a car gets into an accident, it's put under an immense load. And when you're using SPR rivets with adhesives, it helps spread that load out across the joint. And the SPR is just making sure that the panel stays in contact with while the adhesive dries. But there is some strength. So to do a test sample on an SPR and do a destructive test, you can easily do that. You can easily do a peel test with vice grips, and you're going to rip that joint apart. It's really not going to provide any value because you guys don't have any way in a shop to actually measure the strength of the joint. So, you know, for that particular reason, I don't think it's necessary to test an SPR. And on a blind rivet, just get a good blind rivet tool. And that's the best advice I can say. I mean, you could do a destructive test on a blind rivet tool, but again, there's no way to physically measure when the joint failed or when the rivet failed. So it's difficult. Just have good quality rivet tools and you'll be fine, and follow the procedures.
All right, last question. This is another good one here too, I think. Are rivet dies for SPRs considered a consumable item? Because they do certainly wear out, don't they?
Yes. Great question. I'm glad that was asked. So the TKR dies, I'm going to use ours as an example, that Carliner sells. They thread in, and a lot of rivet tools out there have thread in mandrels, thread in dies. Yes, these are consumable parts. One thing that I see over and over again is, again, people don't realize the immense pressure that these things are being put under. You know, I say 6 tons, 60 kilonewton. Everyone's like, yeah, whatever. What does that mean? I don't, you know, it's hard for me to even say. It's like, you know, putting your finger in a vise and clamping it down super tight. It's an immense amount of pressure. But the mandrels loosen up as you're installing them because of the immense pressure. And especially sometimes you'll install the rivet and the mandrel will get kind of hung up on the backside, on the button, on the backside of the SPR. And you start shaking it and wiggling it, you're loosening the dies. So again, these things are consumable. I mean, they don't have an infinite lifespan. They can last a long time as long as you tighten them. And I always recommend, until you get comfortable with the rivet tools, tighten them after every rivet. And you go, really? I mean, I'm not talking about torquing it down with a crescent wrench. They come with little wrenches with the rivet tools. Just snug. But you'll see, once you get comfortable and you start using the SPR rivet tool more, you'll see that you'll notice when the die starts loosening up. And what happens is it loosens up and it backs out, and then you have all those 6 ton, that 60 kilonewton of pressure coming down on those little tiny threads, and it snaps the die. So yes, I do consider these mandrels, they are consumable, and they do wear out. So they're not, you know, it's kind of like a spot welding cap. You know, they don't have an infinite life in them. That's a good question.
Great question. All right. Well, I think that will do it. Kelly, thank you very much for your time, and many thanks to Carolina for sponsoring this particular webinar. For a replay, it will be available later. So as soon as it's done, I will upload it for Kristen to get published at some point. And we are done for the day, but that doesn't mean we're done. We've got another great lineup starting tomorrow morning. So we've got Opus coming in. You may know them as Drew Technologies, talking about best practice for ADAS scanning and calibration. This can be a Spanish version. So for those of you that may have some Spanish technicians or Spanish peers, we'd love to have you join in tomorrow for that one. So we're looking forward to that one. That's let me just confirm, I believe it's at 10 a.m. tomorrow. Yeah, 11 a.m. Central Time tomorrow with Opus. And then I'll be back at 1 o'clock tomorrow with John Shoemaker from BAS talking about production planning to improve efficiency. So with that, everybody, again, thank you for your time and have a great evening. Again, Kelly, thanks for everything. Appreciate it.
Yeah, thanks, Jason. Enjoyed it.